Yes.
All right. So there are, I mean, this is standard question in any testing interview as well. What are the test case design techniques? Any of you can actually give me some keywords so that we can start with. Okay, anyone? What are the test case design techniques?
Boundary value analysis.
Sorry.
Okay, boundary
Yeah. Continue.
value analysis,
Equivalence partition,
equivalence partition. What else?
error guessing,
Error guessing. What else?
Decision table.
Okay, yes. What else?
State transition.
Okay. State transition diagram or table, whatever you call it.
Yes.
Any other test case design techniques that anybody knows? Okay, we'll stop at this. These are enough number of techniques. Let me ask you this: how many of you have actually used any of these techniques? Everyone uses boundary value analysis day in and day out. Do you guys really make conscious effort to create test cases using boundary value analysis? Yes or no? Okay. If
Yes.
okay, one yes. Okay, so I take that as yes. Equivalence partitioning.
Yes. Mostly.
Okay, mostly I take one yes. Okay, error guessing. How about that?
Yes.
There are two yes. That's nice. Okay, decision table.
Yes.
Okay, one yes. Anybody else? This is most, I mean, mostly used techniques, but we will see which one is most popular. State transition diagram. Has anybody actually used it while creating test cases? Day-to-day test case design.
Yes.
Okay, I see one yes. Okay. So I see that error guessing is most popular. We will start with that. But we will cover boundary value analysis, equivalence partition, and decision table today. If time permits, then we can get into state transition diagram. Make sense? All right. So let's first understand the difference between what is a test and what is test case or what is test scenario. Everybody understands the difference. What is a test case and what is test scenario? Can anybody tell me what is the difference?
Test cases are number of steps that we executed while executing test on application, and test scenario is a possibility or condition where we consider for a specific functionality.
Yeah. So we have test cases are very detailed. It has ID, step, expected result, and actual result if it goes like that. But test scenario are one-liner mostly, right? Very brief.
Yeah.
So one-liner mostly. An example is verify that user is able to log in with valid credential, right? So those are test scenarios. I mean, you can see that test scenarios are sometimes very vague. They are very dependent on the domain and product knowledge, whereas test cases are very detailed. Even if you give them to a person who does not know the application, he can also execute the test case because it does not depend on the application or domain knowledge. So that is a basic difference between test scenario and test cases. Sometimes people assume or see test scenario as a superset of test cases. So one test scenario might get bifurcated into multiple test cases. That is true. Sometimes there is one-to-one mapping between test scenario and test cases. It depends on how detailed you are in writing test scenarios or test cases. Test cases, as I mentioned in my first session about where we are trending, lot of people are now not writing very detailed test cases. They want to abstract and invest less time in writing test cases. That's why they switch to test scenarios. This is very human intensive work, writing very detailed test cases so that you can execute that in later phases of test execution. But anybody who is familiar with testing, they would at least write one-liner test scenarios for testing and making sure that they are either passing it or failing it in the test management tool. Most of the time you write one-liner test scenarios, and then if you have time, then put that into detailed test cases. Tools like Jira, Zephyr, um, or Quality Center or Mercury Quality Center. Those tools are used to create detailed test cases. Understood? Any question on difference between test scenario, test cases? All right, let's talk about error guessing. Let's change the color. So what is error guessing? And how do you guess errors? Is testing all about guessing? So let's say there is a text box, okay, which accept values from 0 to 100. I want you people to apply error guessing to this one text box and tell me what are the test cases. Okay. First of all, do not apply boundary value analysis or equivalence partitioning if you know that technique. Okay. I just want you to apply error guessing. What does error guessing mean? Once you apply it, once we have more examples, I will also illustrate what is the definition, right? The definition is in the. So guess the errors. What could the error be?
Error guessing is nothing but predicting the inputs by referring to requirement document, which is not covered boundary value analysis and equivalence partition as well.
Okay.
But in this example, if we are considering the box having 0 to 100 numbers, then we can pass any alphabet, negative numbers, special characters, or operators.
Okay. So you can add alphabets A to Z or A to Z, right? You can add special characters like star, slash, hyphen, whatnot. Okay. What else?
Negative numbers and special characters, operators.
Okay. Equal to, plus, minus, question mark, ampersand, and whatnot. So all the special characters as well we covered.
Leave blank without passing anything.
Okay, blank. Where does this come from? How did you come up with all these scenarios?
Because we know that we have to pass 0 to 100 numbers. So for valid test cases, we can pass between 0 to 100. And for invalid, we can pass less than 0 or greater than 100, like that. So instead of numbers, we can try something different, which is we can guess in a point of that we can get that it will get the error from
Okay.
our.
Yeah, most of the time error guessing comes from your background as an engineer or the domain expert, right? So for example, 0 to
Yeah.
100 is a stated requirement. Okay. So anything that is stated in requirement can be tested, and anything that is not in the requirement can also be tested, right? So 0 to 100 is
Yes.
a valid test case. You can pick up any number from there and you test that it is working. But you have to check if we keep it blank, if we add any additional, special characters, what happens, or operators. If we enter A to Z capital or A to Z small, what happens? If and these are not stated in requirement, right? So how can you now, in your testing phase, you try all of these values, okay, and you see that it is failing here. If you enter A to Z or capital A to Z, it is still accepting. That is a defect, right? It is accepting your special characters as well. So this validation is not proper. It is, even if you keep it blank, it is accepting. Let's say there is a star here that it is a mandatory field. So even if you keep it blank, it is accepting. If you put valid, it is accepting. So all of these are defects, right? We have 3 4 defects here, or you can put all of them into one big defect and say that, okay, if I enter for this field, if I enter alpha characters or special characters, blanks are accepted. Why is this defect detected in testing? We got the build and then we tested and then we found these defects. So yesterday we learned something about prevention, right? So where should the prevention be? Guys, anyone?
We should not pass invalid any data. So for that, we can mention there, we can pass only the numerators or numbers, like that. We can't pass special characters, alphabets, like.
Correct. But where should we mention this? In our
In the requirement
correct. All of these conditions should have been discussed in our requirement phase itself. So if you
initial, yeah.
yeah, plain blunt requirement that it is going to accept values from 0 to 100 and nothing else, then please ask questions in your requirement analysis or grooming session itself. What are the specifics? Is it going to accept alphanumeric? Is it going to accept special characters, commas? Is it integer value or float value? Is it going to accept comma in between? Right? If it is 100, is it going to be like this 100, or is it including 100 or excluding 100? All of those questions should come in your requirement phase itself. If we clarify this in requirement phase. When developers are present, they are going to make sure that they are preventing this from happening in build phase, right? It will not be, it will be captured in your requirement phase. It will be addressed in your design. It will be addressed in coding, at least 3 phases kahi to cover hoga. It will not get into test phase where we will be accruing lot of cost of quality. Do you guys understand the analogy now? Why should you ask these questions in requirement phase, and why should you get involved in grooming your requirements? Is because you can prevent these bugs. You can prevent developer from adding it into your, not thinking about it into your design phase, or not coding it like that. He will address that into his unit test itself, right? Why would we test it if the validations are already considered? And why should we spend time in testing this one field? Kitne test cases honge if we have to consider these cases, right? Every field, every character that we are going to add. This itself will take us like 3-4 hours for us to keep checking all these conditions. We haven't even started into other test case design techniques. Do you understand the magnitude of testing that you do? The amount of effort that you're spending testing one field can multiply depending on what information you have available, or you don't have that information. If developer has tested it and you have discussed with developer, maybe you have reviewed unit test cases as well, then you are comfortable not testing these conditions. These will never happen because you know that developer has completed these test cases into unit testing. And definitely we will have trust issues. We will say that how can I trust you that you have covered these into your unit testing? You can go and verify the code, right? Unit testing code. Typically we don't do that, but that's what error guessing is all about. You have to guess the things those are not mentioned and make sure that you ask questions. If you fail to ask questions in requirement phase, you will not find these conditions ever. Is this test case going to contain, I mean, is this um, text box going to be mandatory field or not mandatory? Can I keep it blank? Is it going to accept any alphanumeric characters, alpha characters numeric we have? Is it going to accept any special characters? Always ask these questions for any input box or any requirement that is stated. Anything that is not stated should be asked in your requirement analysis. Clear? Any questions for error guessing? It is domain specific, as I said, because sometimes you would want to guess something which is very specific to the domain. For example, mathematics, right? If there are two numbers and they are getting divided, a divided by b, if a b is 0, then we cannot divide any number by 0, right? That is error guessing. You must know arithmetic operations to guess this error. That's why it is dependent on your knowledge of that specific domain. Make sense? All right. Any questions, guys? Anyone? All right. Let's move on. If we have no questions, that's good. Seems like everybody is getting this. All right, let's talk about equivalence partitioning now. I'll take the same example or maybe a little different one. We have, let's say, same text box, which is accepting values from 0 to 100. Now, what is equivalence class and what is the equivalence partitioning test case design technique? Anyone? And why we use it? Okay, stated requirement is 0 to 100. We have already covered error guessing part. We will not get any other value, or it will not be entered itself. This is a mandatory field. So all of those are covered in our error guessing. Now let's focus on just using equivalence partitioning. Anyone?
Yes, sir, we divide requirement into different phases, valid, invalid. First phase we consider 0 to 10, 11 to 20. For negative, we can consider before 0 and after 100. Like this, we divide this all requirement into number of phases.
Yeah, so we divide our inputs into equivalence classes, and equivalence class is a mathematical term used for putting a class together. Any input value from that particular equivalence class will yield a similar result, right? So in this case, anything which is greater than 100 will have the similar result on the output. So even if you take 110 or 150, the result will be same, that this text box is not going to accept anything greater than 100. So that's why you choose one condition out of that equivalence class. This is your negative equivalence class. Similarly, in this case, anything which is less than 0, whether it is -5 or -25 or any other value, you are going to get similar output. It is not going to accept anything less than 10. So you choose one value out of this. And anything in between, anything 0 to 100 is going to be accepted. So this is your positive equivalence class. So you have two negative equivalence classes, anything less than 0, anything greater than 0, and one positive equivalence class, and you choose one value out of that. So you have 3 test cases, which is going to cover the gamut of all the test cases here. If you just go by number of combinations that you can do, if you are doing, let's say, exhaustive testing, any value which is out there in the world can be potential input for this input box. So you can enter values from 0 to 100 one at a time. You can enter any value greater than 100 one at a time, and it goes to infinity. Everybody understands this infinity concept, right? There is no end to this. You can go from 100 to infinity, 0 to negative infinity, to check values for this input box, and then you will keep testing this input box forever. That's what we're trying to avoid. This testing technique actually limits the number of inputs to minimal set of inputs so that we can test using this 3 values only and verify that those work. Right? So this testing technique actually limits the number of inputs so that we don't do very exhaustive testing. This represents the values we should be testing with. Any questions on this equivalence partitioning testing technique? Always remember to create positive and negative equivalence classes. No inputs, no questions. All right, now let's talk about from input, let's convert the example to output, right? If I enter values from 0 to 100 in this box, only then I'm going to get, there are two, let's say, check boxes or, images. You will have this check sign and cross sign. And if you have values from 0 to 100 only, then this sign will be enabled. Otherwise, this sign will be enabled. So to get this sign enabled, you have to make sure that you enter values from 0 to 100, right? So you have to also consider what is the outcome or output of your test cases when you are considering equivalence classes. Assume that you don't have this boundary, but you have stated requirement 0 to 100 is your valid input. Then this checkbox will be entered. Maybe I can give you another example later in this session about how you can focus on outputs. That will come into decision tables more. It will be more prevalent there. But equivalence class, you guys are clear?
Yes.
Okay, let's move on to next one, which is boundary value analysis, and let's change the color. Let's be colorful. Okay, what is boundary value analysis? Same example. Should we take that same example? 0 to 100. Okay. Now somebody can illuminate, elaborate.
Here we check the condition at boundary levels.
Okay. So what are the boundaries here?
0 +1 -1 at both levels.
Okay. So we focus on boundaries in boundary value analysis. So +1 is one boundary here, -1 is one boundary here. Let's say 99 is one boundary here, boundary value is 100, and we have 101. Okay, so this is very simple technique where if we have range or even if we don't have range, we focus on the boundaries of that specific value or input value. Here we are checking whether 99 is accepted, 100 is accepted, and 101 is rejected. Um, because our condition is 0 and 100 are all inclusive, right? So it accepts 0 as well. Now 0 is accepted, +1 is accepted, -1 is not accepted. By the way, why do we do this boundary value analysis? What is the real reason behind it? Has anybody done coding for such conditions to accept or reject values from 0 to 100? Everybody does knows Java, right? Let's say we have to accept values in your method parameter, and we have to write if condition. And let's say if n is greater than 0, right? And n is less than 100. And whatever status equal to OK, right? Very simple code. N is greater than 0 and n is less than 100. Then we're accepting that value. Else we are status equal to not OK. Very simple pseudo code. Now in this code, what is the problem here?
Actually, we did not consider 0 value here.
Okay, let's say we are considering 0. What do I have to do here?
Equal to sign we have.
Okay.
Customer equal.
I need to make sure that I'm putting equal to here because a requirement is we have to have 0 and 100 as inclusive. Those are included in that range. So both for n greater than 0 and n less than 100, I have to put equal to so that that range is considered, right? These are the places where developers make most of the mistakes. We tend to forget the boundaries, and that's why boundary value analysis technique exists, because people tend to make mistakes on the boundaries, and most of the mistakes happen there. That's why we have to make sure that we use this technique. Now you understand why this technique is important, right? Because you have an example now.
Sir, what is the difference of that equivalent value testing and this boundary value, equivalence partition and this?
Yeah, very good question. Now the difference is, now you have equivalence classes here as well, right? You have negative equivalence class and you have positive equivalence class. So if you are using equivalence class, your 101 is actually a negative equivalence class. It should not be accepted. Your -1 is your negative equivalence class and it should not be accepted. Your +1 is actually part of your positive equivalence class. It should be accepted, and 99 should also be accepted. So you can marry both your boundary value analysis and equivalence partitioning. Make sure that you are including one representative other than your boundary condition. Okay, let's say -1 is considered as your test case, 0 is considered as your test case, +1 is considered as your test case, 99, 100, and 101. You have to take at least one representative other than your boundary value analysis, let's say, which is 110 in your case. And in this case, I can take -25 or whatever value you want to select. The reason being, as I said, what if this condition I am going to, let's say, change, right? Now, developer is writing this little differently. N is greater than -1 and N is less than 101. Got it? In less than a minute, we are going to drop off and come back to this same meeting. But you understand the difference, right? The range still stays the same. A very enthusiastic developer is going to write like this: n is greater than -1 and n is less than 101. Now he has written well, the 100 and 0 and 100 are inclusive. But what if he makes a mistake like this? He puts equal to there. In that case, -1 is included. 101 is included. That's why you have to at least take one condition other than your boundary condition, which is +1 and -1. Does that answer your question?
Yes, sir.
Now, once we come back, I'll tell you how to use partitioning effectively to reduce number of equivalence classes. Let's come back to this same session again. Please join back.